Okay, so good morning, students. Am I audible to you? Can you hear me and can you see the screen clearly? If yes, please say yes in the comment box. Good morning, all of you. So can you see the screen clearly? Okay, fine. So then we'll start today's session. So if you recall previous lectures of complex calculus, since we had some break in between, so I thought of quickly recalling the things. So if you see that. So if you see in complex numbers that if you see the topics that we discussed, so we have started with the basics of complex numbers. Then after we have discussed some basic algebra of complex numbers, like basically multiplication of two complex numbers, then division of two complex numbers, and all these things. Correct. And after this, we have started, something called differentiation and continuity and differentiation of complex functions. We have seen what are different types of complex functions, basically the log function, exponential function, and all these things. And then we have started looking at differentiability of these complex functions. Correct. Once we have seen whether a complex function is differentiable or not, we have seen what is analyticity of a function, means we have seen what are analytic functions, and we have seen the mathematical conditions that are supporting the analyticity of the function. Correct. And after that, while closing the lectures, we have solved few gate problems of previous years in complex variables, and then we have started complex integration. Correct. So if you recall things quickly, so this is the thing that we are discussing in the last class. Correct. I gave you some introduction about complex integration, like how to integrate if this f of z is of the form u plus iv, where both u and v are functions of x comma y, and if z is x plus iy, then dz is equal to dx plus idy. So if this is the case, I told you how to follow the things, and this is where we have ended with. Correct. So we'll start our discussion from this point here. Okay. So see here. If f of z is a complex function and f of z is equal to u plus iv, where u comma v are functions in terms of x and y, functions in terms of x and y, then the integration of f of z, then the integration of f of z along a path C is given by the line integral I is equal to integral over C f of z dz. Correct. So when we have f of z as u plus iv and dz as dx plus idy, let us expand these terms along the term C, u plus iv into dx plus I dy. So this is equal to, along the path C, now u into dx is u dx plus iv into I dy. I into I is -1, so I square is -1, so minus v dy. So this is the real part of the integration, plus I into, so if you see v into dx plus u into dy. This is what we have seen in last class. So basically, if you want to evaluate any integration of a complex function along any path C, for which f of z is of the form u plus iv and z is equal to x plus iy, this is how you will be integrating the things. Okay, so, and I also told you, if this f of z is analytic, then this integration is independent of the path. Means, for example, if this path C is in between 2 points A and B, then if f of z is analytic, this integration is independent of the path. As we have seen in vector calculus case, if f bar is a vector point function, then basically this line integral f bar dot dr bar is independent of the path. In a similar case, if this f of z is analytic, then definitely this integration is independent of the path that you are carrying out this integration. Means you can take to any path. The answer remains same. Okay. So this much we have learned. So based on this logic, now if this f of z is of this form u plus iv, then this integration can be evaluated using this term. So let us solve one example, so you'll get the things. Okay. So see here, the value of integral 0 to 2 plus I. So basically in real calculus we see real limits, and in complex calculus we can have complex limits as well. So integral 0 to 2 plus I, z conjugate whole square dz. Of course, you know z is x plus iy, so z conjugate is x minus iy. Along the real axis 2 to 0 and then vertically to 2 plus I is a plus ib. Means if you evaluate this integral along some path which is given, the answer is of the form a plus bi or a plus ib form. Then the value of a plus b is dash. So let us see here. Solution. Let us try to solve this question. Okay. Given integrand z bar square is equal to x square x minus iy whole square, correct? So if you see x minus iy whole square, so this is equal to x square plus iy whole square is minus y square plus I into x into minus iy, so this is minus 2xy. So if you see, the integrand is x square minus y square minus 2xy into I. This is the integrand. So now if you write this integral z conjugate whole square dz, we have integral over c x square minus y square minus 2xy into I to this whole multiplication dx plus I dy. Correct? So see here, this is equal to integration. Now if you multiply the things, x square minus y square into dx. So x square minus y square into dx. Next, if you multiply these two terms, you will be having minus 2xy into I dy. So this completely will give you 2xy dy, because I square into minus 1 is already 1. So 2xy dy. So this is a real part in the integration plus I into. Now if you multiply this term with this particular term, you have x square minus y square dy plus, again if you multiply these two terms, you have minus 2xy dx. So this is minus 2xy dx, minus 2xy dx. So this is the integration that you need to carry out. Basically this is complete thing is the integrand. Now once we get this thing, we need to look at this path c. Now let us see what's the path c. If you see the integration limits 0, this is the real axis and this is imaginary axis, for example. So now if you see clearly, the value of this integration from 0 to 2 plus I, you know this point 2 0 comma 0 is this origin itself. Let me change color so you can see the things. This is 0 comma 0 o, correct? Now let us suppose this point 2 plus I, you know this 2 plus I denotes the point 2 comma 1 in the argand plane. Yes or no? Because the complex number x plus iy will represent x comma y point in the argand plane. So if this is 2 comma 1, now he is defining the path by this statement. See, the path is the value of this integral from 0 to 2 plus I along the real axis to 2 comma 0. So first if you take this 2 comma 0, this point here, the path that is specified is along the real axis to 2 comma 0. Then vertically to 2 plus I, means from here it's again going vertically upwards to this point. So it is reaching 2 plus I in this particular path. Correct? So now let us try to evaluate this integration along this path. And if you see, these two are two different paths. It's not a single continuous path. Correct? There is some change in the nature of the function. So let us name this point as a and this point as a b. So this implies integral over c f of z dz is equal to evaluation of this function along OA and then along AB. Okay. So let us write this value completely once. See, I'm solving this example so that you'll understand how to apply path. The things are very much similar to the line integrals that we evaluated in vector calculus. Okay, so that's why I have spent more time in evaluating line integrals in vector calculus, because that could help you out here. Okay, so let us write the things. Therefore, I is equal to integration along path OA f of z dz plus integration along path AB f of z dz. So now let us see the function that we have. Integration, see, x square minus y square dx plus 2xy dy. So let us write that x square minus y square dx plus 2xy dy. So this is the function plus I into see, what do we have here? X square minus y square dy minus 2xy dx. So x square minus y square dy minus 2xy dx. This is what we have. Now we need to integrate this along path OB. But since this OB has been split into two paths, OA and AB, let us see. Along OA, y is equal to 0, yes or no? Because the path O to A is along the yield axis. And if you are moving along the yield axis, this y coordinate of this point is of any point in the arcgand plane, which is on x-axis, is 0. So along OA, you have y is equal to 0. So this implies dy is equal to 0. Along AB, x value is constant, yes or no? Because the line is vertical, so you know x is 2. So what does this imply? Dx is equal to 0. So along path OA, you can put y is equal to 0 and dy is equal to 0, and x changes from 0 to 2, yes or no? Because the line segment is moving from 0, 0 to 2, 0. So x changes from 0, 0 to 2, 0. Since we are writing only x, we can write x changes from 0 to 2. And here in this case, what does y changes to? And y changes from 0 to 1. Correct? Because if you 0 to 1, because if you see this line segment here, this is the equation x is equal to 2. Correct? Because if you see, this is a straight line, which is of course vertical. So since this is a vertical line, x is constant along this path. So x is constant at 2 and y is changing from 0 to 1. So let us apply all these conditions in this case. Okay, so see here. Therefore, I is equal to, look, first of all, let us evaluate along the path OA. Okay, so along path OA, which is this function with x is equal to, x is x, but y is 0. So if you put y is equal to 0 and dy is equal to 0 in this function, along OA, x is changing from 0 to 2. So x is changing from 0 to 2 along OA. Now along OA, y is equal to 0, which means this term will be represented as x square dx. Next, this dy is 0, so this term doesn't have any significance here. Plus I into, now, we can do by substituting x is equal to 2. You can directly have your complex integration as well, but I want to show little geometry here, so I'm dealing all these things. Okay, so plus I into, now if you take y is equal to 0 here, this dy term is 0 and this term is also 0, because we have dy here and you have y is equal to 0 here. So this term completely goes to 0. So this value is along path OA. Plus now along path AB. Now y is changing from 0 to 1. Okay. Now in this, if you put x is equal to 2 and dx is equal to 0, this dx term, first term is considering this dx. So this term is 0 plus 2xy dy plus 2, value of x is 2 along this line, 2xy dy. Okay, plus I into x square minus y square, 4 minus y square dy, because x value is 2 and this dx is 0. So this is the total integration value that you will be getting here. So did you all understand how did I achieve this step? This is completely an integration of single variable in terms of y, and we have the y limits changing from y is equal to 0 to y is equal to 1, and this is completely an integration in terms of x. Now did you all understand how did we attain this step? How I have substituted this x is equal to 2, y is equal to 0 and all these things in this along two different paths. Did you all understand this? I just want to give you the idea of how to evaluate complex integrals. I want all of you to respond. See, nearly some 42 online, so please respond if you understand this, how we achieved this particular step till here. Okay, so now it's a simple calculation that you could do. Integral of x square is x cubed by 3 within the limits 0 to 2, plus this is 4y, so integration of 4y is 2y square. 2y square plus I into integration of 4 minus y square is 4y minus y cube by 3 within the limits 0 to 1. So if you evaluate this value, if you put 2 here, this is 8 by 3 minus 0 anyhow, so it's 0, plus when you put 1 here, this is 2 into 1, so 2, plus I into When you put 1 here, 4 minus 1 by 3, which is 11 by 3. So this is the value. So if you simplify the things, we have 6 14 by 3 plus I into 11 by 3. This is the value of this integration. Okay. See, I have done a bit long because I just want to show you geometrically how you are taking the path. As same in vector calculus, line integrals, we have done one more time here. Okay. So this is just 1-2 steps that we have here. So once you get this, just substituting these conditions and then getting the answers. Yeah, 14 by 3 plus I into 11 by 3. So this is given as A plus IB. So the value of A plus B is 14 by 3 plus 11 by 3, which is 25 by 3 and which is 8.33. Okay. So the answer is 25 by 3, which is equal to 8 3s are 24 and we have 1 left. So 8.33. You can round off to 2 decimals. Okay. So did you all understand this? It's a simple, just integration based on the geometry. But I want to show you why along path OA I am taking y as 0 and y along path AB I am taking x as 2 as a constant. Okay, because this is a real, this is a line segment on the real axis, so y is equal to 0. Okay, so see here, we'll go for the next part. Okay, so I told you if f of z is analytic, the function, the integration is independent of the path, and suppose if the path C is closed, we denote with a cyclic integral f of z dz. This is what we have learned, correct? So now we'll learn some important point in complex integration. If, okay, no if, let us write the statement straight away. The value of the integral I is equal to integral over C z minus a whole power n dz is equal to 0 if n not equal to minus 1, 2 pi I if n is equal to minus 1, where C is modulus of z minus a is equal to r. Means basically the C is a simple closed curve. I told you what is a simple closed curve. The curve in between, except at the final and initial point, it should not intersect or touch in between, correct? And if you see, this equation is a circle with center a comma 0 and radius r. So this is a simple closed curve. So if you see, let us suppose this is some a comma 0 and then this could be some reasonably a circle where mod z minus a is equal to r. So if this is the case, so see here, solution. Now, if I take any point on this circle, the distance from this means if you take this modulus of z minus a, that is definitely equal to r, correct? So I can write point is on the curve, mod z minus a is equal to r. So we can write z is equal to, or else we can write z minus a is equal to r into e power I theta, because if you see this modulus, if you take always this, the distance between this z and this point a comma 0 is r, but since the point location is changing, which can be compensated by this theta, where theta varies from 0 to 2 pi, where theta varies from 0 to 2 pi. Okay, so let us see why this result is getting valid, because many times questions have been asked in GATE examination with different values of n here, but with the same case. Okay, they'll give you some cycle, because this a and r are independent variables, you can change them as of your wish and you can change this n value. So I want to teach you this with a general sense by putting n, a and r here. Okay, so if this is the case, see, case 1, if n is equal to minus 1, okay, means basically if n is equal to minus 1, we told the value of this integration is 2 pi I. So we shall see this. I is equal to integral over C, look here, z minus a whole power minus 1, and you know z minus a is r into e power I theta. So z minus a whole power minus 1 means basically this value whole to the power minus 1 will give you 1 by r into e power I theta. Okay, see, this r is a constant, correct? This r radius is a constant, but only theta is varying. So if you see, instead of writing C here, we can write straight away the limits theta is equal to 0 to theta is equal to 2 pi. Okay, into, now see here, dz. For the substitution of this dz, look, we have z minus a is equal to r into e power I theta. So if you differentiate this with respect to theta, because your limits of integration are in terms of theta, so dz is equal to r into e power I theta. Integration of this is e power I theta into I d theta. This is what we have, correct? Because if you integrate this function with respect to theta, definitely you will be getting this term. So now we can cancel this r and e power I theta. Then you have this I into integral 0 to 2 pi. Of course, these are theta limits, d theta. So if you integrate this I into theta within the limits 0 to 2 pi, and the answer is 2 pi I, which I have stated here. When n is equal to -1, the answer is 2 pi I, and that's what we obtained here. Okay, next, let us look at the next case. Okay, so let us look at this next case. Case 2. If n not equal to -1, let us see what happens. I is equal to integral theta is equal to 0 to theta is equal to 2 pi. See here, when n is not equal to -1, this z minus a can be replaced with this r into e power I theta. So this is r power n into e power I theta whole power n into this dz is again, this is what we have, r into e power I theta into I d theta. This is equal to, see here, there is one r power n into one r, so this is r power n plus 1. So r power n plus 1 into e power I n theta into e power I theta. Of course, this I is also a constant, so we can write this I out of the integration. Now theta is equal to 0 to theta is equal to 2 pi. Now this e power I theta whole power n can be written as e power I n theta into e power I theta is also there. So can we write plus I theta here? We can write that d theta. So now if you evaluate this integration, see, I into r power n plus 1 into, look, if I take I theta common, you have n plus 1 here. So if you integrate this, we have e power I theta into n plus 1 divided by I into n plus 1. Okay? Because if you take I theta common, you have n plus 1 here. So since theta is the only integrating variable, this I into n plus 1 is a constant with respect to theta. So these limits are changing from theta is equal to 0 to theta is equal to 2 pi. So now this I gets cancelled, of course. R power n plus 1 divided by n plus 1 is a constant. So this is equal to r power n plus 1 divided by n plus 1 into, so see here, if n is not equal to -1, then see what happens. This is, did we write something wrong here anywhere? I hope things are going fine. Is that okay to all of you? Clear so far? Okay, so shall we go for the substitution? Okay, so see here, e power I of n plus 1 into 2 pi, e power I of n plus 1 into 2 pi minus e power 0 is 1. And if you see, the value of this bracket is 0, because if I multiply these two here, look, see carefully, this bracket is 0. I am explaining you why this bracket is 0. N plus 1 into 2 pi is here, correct? So if you write these two ahead, you have 2 times of n plus 1 into pi, and 2 times of n plus 1 is an even number, correct? And if you know even multiples of pi, I mean cos of even multiples of pi is 1 and sine of even multiples of pi is 0. Since this power is of even multiples of pi, this e power I into this even multiples of pi is 1. So this is 1 minus 1 and this value is 0. Clear? So this is 0 because this is e power I n. See, I want to tell you one thing, I n pi. If n is even, then you know this can be written as cos n pi plus I sin n pi. And you know this sin n pi is 0 for all integral multiples of pi. And this cos n pi, if n is even, this value is 1. So as long as this is even number, this value of e power I into n plus 1 into 2 pi is 1. So 1 minus 1 will give you 0. So the answer is 0 if n is not is equal to -1, which is supporting this case. Okay, so in gate examination, many times they are putting different values for n and different, you know, these two are arbitrary, so they can put whatever they want and they're asking these questions. So, but this is the generalized result. If n is not equal to -1, then the answer is 0. And if n is equal to -1, the answer is 2 pi I. So are you all clear with this? Did you all understand why this bracketed term is 0? If yes, please say yes in the comment box, or if you have some difficulty, please let me know. Yes, I want all of you to respond. Okay, so I'm moving ahead now. Can I move? Okay, once explain. Okay, Venkat Nagisa, you want me to explain? So basically, once again, second case. Okay, see here. This z minus a, we have assumed this as r into e power I theta. Correct? So z minus a whole power n will give you r power n into e power I theta whole power n. Clear? Into dz. If you differentiate this equation on both sides with respect to theta, then you have dz is equal to, since a is a constant, differentiation of a with respect to theta is 0 is equal to, since this r is also a constant, so we have the dz as r into e power I theta, and we are differentiating with respect to theta, so this I is an inner multiple here, I mean of this theta, so we'll be getting this I as a multiplication, so I into d theta. So this is dz which I have already used here, r into e power I theta into I d theta. So now if this is the case, since we are integrating with respect to theta, because this distance r is fixed at any point with respect to this center, so this r power n plus 1, I am taking it out as a constant, and this I is also an operator, I am taking it out. So theta is equal to 0 to 2 pi. We have, see, this is e power I theta whole power n. You have a power m whole power n is equal to a power mn. So I can multiply this I theta with this n straight away, and I can write e power I n theta into e power I theta. And a power m into a power n can be written as a power m plus n. So I have added this I n theta plus I theta d theta. Now this r power n plus 1 into I is a constant, I have written here. Now if you integrate this, see, this is nothing but e power I n theta plus I theta. So this, if I take if I take I theta common, we have n plus 1, correct? So I into n plus 1 is a constant with respect to theta. So if you are integrating this term, you will be having e power I theta of n plus 1 divided by the multiple of this theta is I into n plus 1. So you will be having that I into n plus 1 once again in the denominator. Within the limits, theta is equal to 0 to theta is equal to 2 pi. So if you cancel this i's, you have r power n plus 1 which is lying here divided by this n plus 1 here into, now if you substitute the limits, e power I n plus 1, see, this I into theta into n plus 1 can be written as I into n plus 1 into theta, and when you are substituting upper limit for theta, you have 2 pi minus, when you are substituting lower limit for theta, when you are putting 0 in place of theta, e power 0 into something is e power 0, and the value of e power 0 is 1. And I told you why this value is 1, correct? Because if you are multiplying these two in front of this n plus 1, this e power I into even multiples of pi, and even multiples of pi, when you write in e power I theta form, will give you 1. So cos n pi plus I sin n pi, when n is even multiple of pi, for any multiples of pi, this sin n pi is 0. For even multiples of pi, this cos of n pi is 1. So 1 minus 1 will give you 0. Okay. So that's how this is 0 if n is not equal to minus 1, and 2 pi I when n is equal to minus 1. So there are two questions that have been asked in exam. The value of cyclic integral c 1 by z minus a dz, where c is the curve, mod of z minus a is equal to r is dash. So this is the the question that was asked in examination. In that case, you'll get minus 2, correct? Pain C, if there is odd multiples of pi, then definitely sine of odd multiples of pi is 0, but cos of odd multiples of pi is minus 1. So minus 1, you'll get minus 2 ahead. Okay, so the answer could be something like minus 2 into r power n plus 1 divided by n plus 1. Okay, Pain? So see here. What's the answer for this? 2 pi I, correct? Because this is nothing but integral over c z minus a whole power minus 1 dz, where c is mod z minus a is equal to r. Just now we have discussed the case when there is minus 1, means when the value of n is minus 1, the answer for this integration is 2 pi I. So the answer for this is straight away 2 pi I. Okay, so by learning that result that we discussed just now, it's helpful for us in solving such questions if they are asked in GATE examination. If you don't know this result, now you need to substitute those things which I have done in showing you the result, and you need to analyze the things. Means basically you need to do this part again. Means this case 1 which I have dealt here, you need to do that again every time when they change the figures. What's the answer for this question? The value of integral c z minus a whole square dz, where c is given by modulus of z minus a is equal to r. 0 straight away, because you know this is not equal to -1, so definitely the answer is 0. Yes, all of you are correct. Shravya, Nagasat, Jyothna and all. So did you all understand? When n is equal to -1, the answer could be something like 2 pi into I, but when n is not equal to -1, the answer is straight away 0. You can go for things like this. Okay, actually, by looking at this function, you can tell this. How I let you know, because there is something called Cauchy's integral theorem, and we'll learn what is that Cauchy's integral theorem in a short time. Okay. Okay, you can write if you want. We have solution if you want to write. I would like to repeat. We have integral over c z minus a whole power n dz is equal to 0, n not equal to -1, 2 pi I, n is equal to -1. So since n is equal to 2, which is not equal to -1, then integral over c z minus a whole square dz is equal to 0 when c is modulus of z minus a is equal to r. Okay, so this is what we have. So next I would like to discuss one thing, something called Cauchy's integral theorem. Cauchy's integral theorem. We'll see what is this Cauchy's integral theorem. Okay, so see here, if f of z is analytic function at every point within a closed path C, within a closed path C, and f dash of z is continuous, means basically the first derivative should be continuous at every point. And I mentioned the path C is closed. Then integral over C f of z dz is 0. This result is really important because there comes a lot of questions in GATE examination, and generally if question comes from complex integration in GATE examination, questions comes from 3 parts in general. If you analyze previous papers, out of those 3 parts, one part is this Cauchy's integral theorem. Okay, so I request all of you to pay some attention towards this and don't write the notes when I'm teaching you, because I want you to observe these things that are happening here. Okay, so let us see. Suppose if there is some closed path C, of course we are evaluating in anti-clock sense, and let us suppose this is a real part of z and this is 0 and this is imaginary part of z, and let this f of z is analytic at every point within this closed path C. Okay, at every point. Then first of all, solution. If f of z is of the form u plus iv, and means basically you want to get some functions of x comma y, which you already know, and z is x plus iy, so dz is equal to dx plus I dy. So now if you see here, I is equal to integration of the path C. Of course this C is a closed path, so that's why I have indicated with the circle on the integral. Generally the circles on the integral denote closed paths. Okay, so now if you multiply this f of z into dz, as we have u dx minus v dy plus I into v dx plus u dy. This is what we have. Correct? Now if you see this, can we split this integration at cyclic integral over c u dx minus v dy plus I into cyclic integral over c v dx plus u dy. Can we split it like this? Because you know all integration symbols or all integration operators can be split at plus and minus signs. So if you do this, now see clearly. What do we have here? I is equal to cyclic integral over c u dx minus v dy plus I into cyclic integral over c v dx minus u dy. I mean, sorry, plus u dy. Correct? V dx plus u dy. Is that we have v dx plus u dy? Okay. So see here, given f of z is equal to u plus iy is analytic. Is analytic. Correct? Now if f of z is equal to u plus iv is analytic, definitely it should satisfy Cauchy-Riemann equations. Correct? So CR equations, if you see what are CR equations, we have dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So if you know these two things, yeah, of course, it doesn't depend upon the path. But right now, we are since evaluating along this closed path. See, I told you, see, if the path is closed, then definitely you should have some defined geometry for the path. But if the path is open, then there are just 2 points, initial and final points, and that is independent of the path. Okay, Manoj. But here path is defined since the curve is given as closed curve. Definitely there is some path for that curve. So these are the 2 Cauchy-Riemann equations. Correct. Now this is a closed integral in 2 variables because see clearly. Yeah, correct. No, there is minus sign here. Dou v by dou y is equal to minus dou v by dou x. Nagasai, you can please look back to the things. So if these are the Cauchy-Riemann equations, see what happens. Now this is a line integral in 2 variables, correct? Because u is a function of x comma y and v is also a function of x comma y, which means this particular term is a function in 2 variables. And if you see, this is closed path. If you remember Green's theorem in vector calculus, what does Green's theorem tells us? What does Green's theorem tells us? Cyclic integral m dx plus n dy over the path C is equal to double integral over the region R, which is bounded by this path C, into dou n by dou x minus dou m by dou y into dx dy. Correct? This is what we have seen in case of Green's theorem. Means basically, if this is if the integrand itself is a function of 2 variables, and if you are evaluating along the closed path C, which is bounding a region R, then this particular integral is same equal to this double integration over this region R evaluated on this particular integrand, dou n by dou x minus dou m by dou y. So if you see, these 2 are 2 integrals which are to be evaluated along closed paths, and they are also functions of 2 variables. So can we apply Green's theorem for evaluating these 2 integrals? Can we apply that? So if you apply that, this implies I is equal to integral, I mean cyclic integral over C. Okay, let us eliminate this cyclic integral and let us write the region R, where that R is bounded by this closed path. So basically this is region R, which is bounded by this closed path. Okay, so this is equal to double integral over the region R. See carefully, m dx plus n dy. So m value is u and n value is minus v. So dou n by dou x, which is differentiation of this minus v with respect to x partially. So minus dou v by dou x. Correct? Dou n by dou x, since n is minus v, see carefully, I am applying the things very carefully. See here, dou n by dou x, and the value of n is minus v. So dou n by dou x will give you dou of minus v by dou x, and since we can take that minus sign out, we have minus dou v by dou x minus dou m by dou y. And if you see, u is m, so dou m by dou y. This is what we have, dx dy or dy dx, depending upon the limits that you write here, doesn't matter, plus I into double integral over the region R, double integral over the region R, again m dx plus n dy. So dou n by dou x, dou n by dou x minus dou m by dou y, dx dy. This is what we have here. Correct? So now if this function is analytic, if f of z is equal to u plus iv is analytic, then definitely it should satisfy Cauchy-Riemann equations. And what are Cauchy-Riemann equations? These 2 equations that we have here. Dou u by dou y is minus dou v by dou x, and dou u by dou x is dou v by dou y. Now see carefully, this dou u by dou y, which is here, can be replaced with minus dou v by dou x, which means these 2 functions gets cancelled. Yes or no? Because this dou u by dou y is same as minus dou v by dou x. Similarly, if you look at first Cauchy-Riemann equation, this dou u by dou x is same as dou v by dou y. So the integrands in both the integrals goes to 0. So the answer for this is 0. Clear? So that's how, if f of z is analytic, and I told you f dash of z should be continuous because this differential should exist. Dou u by dou x, dou v by dou y, all these terms should exist. So these differentials should be continuous. So you can apply this Cauchy-Riemann equations. Did you all understand why these two terms are getting cancelled? Because if f of z is analytic, it should definitely satisfy Cauchy-Riemann equations, and dou u by dou x is same as dou v by dou y. And we have seen how those Cauchy-Riemann equations are getting formed in the second lecture of complex calculus. Correct? So this answer is 0 because in both the cases, for the real part as well as the imaginary part, the integrand goes to 0. So if f of z is analytic at every point within this path C, then the answer is 0. So if you see this question, this function is analytic at every point because s or no, z minus a whole square. If you simplify z minus a whole square, you will be getting some polynomial function in terms of z square minus 2az plus a square. This is a polynomial function in terms of z. So polynomial functions are continuous and differentiable at any point in general. If they don't have a denominator, then this function is analytic. And if you calculate the first derivative, 2z minus 2a is also continuous at every point. So at every point within a closed path, this function is analytic and the first derivatives are continuous. So definitely if you calculate this cyclic integral, since path is closed for this squared dz, definitely the answer is 0, which is a corollary of this result as well. Okay. Did you all understand why this statement is getting valid? All of you, I want all of you to respond. See, did you all understand why this result is getting valid? Okay. So let me write one important thing here. If f of z is analytic at all points within a closed path C, except in two regions bounded by the paths C1 and C2. Means basically if you have this case, if this is your C, then let us suppose this is C1 and some point here this is C2. So this f of z is analytic at every point out of this C1 and C2. But if you take some point within C1 and within C2, the function is not analytic within the closed paths C1 and C2. If this is the case, then cyclic integral over C f of z dz is same as cyclic integral over C1 f of z dz plus cyclic integral over C2 f of z dz, because except at these two regions at every point the function is analytic. If the function is analytic at except these two regions, then the integration f of z dz with respect to the remaining region will be 0 anyhow, correct? Because the function is analytic there. So this is the result. We can evaluate these results, and we know how to evaluate the complex integration things, so we'll do this. Okay, so before going for the previous gate problems, I would like to give you one theorem which is of much use, and problems are being repeatedly asked on that theorem. That's the second part actually, where questions come from the complex integration. So let us write that. Cauchy's integral formula. Cauchy's integral formula, and this formula is really important for GATE examination, because if you analyze past papers, many questions comes from this Cauchy's integral formula, and we have a few number of good questions as well. So let us see. If f of z is analytic, at every point within a closed path C, and if f of z is equal to phi of z divided by z minus z naught whole power n plus 1. Okay, if f of z is analytic at every point within a closed path C, you can add one letter here except at z naught. Except at z naught, because you know when you put z is equal to z naught, this function doesn't get a finite value, correct? It goes to undefined, because z naught minus z naught will give you 0. So if this is the case, then cyclic integral over this path C f of z dz is equal to cyclic integral over the path C. What is f of z dz? Phi of z divided by z minus z naught whole power n plus 1 dz. Okay, and this function f of z means basically this complete function is analytic at every point within this closed path C. For example, if you have some real part of z, imaginary part of z, and some closed path C, let us suppose this function is analytic at every point except at some point z naught within the path C. Then this value is given by 2 pi I into phi nth derivative at z naught divided by n factorial. This is the value. Okay, so basically cyclic integral over C f of z dz is equal to 2 pi I into phi nth derivative at z naught divided by n factorial. Okay, so this is Cauchy's integral formula, and in tomorrow's lecture I'll tell you why this formula is in such way, means why you are getting this result. Because right now, to explain you this, I need to talk about poles and something called residues, which I didn't do it. But you know, this Cauchy's integral formula is really important for GATE examination, because past papers say that many times questions comes from this Cauchy's integral formula. But the function f of z should be of this format. Okay, so some function in terms of z where this phi of z is continuous and analytic at every you know, point within this C. You can write where then this is equal to this if phi of z comma phi dash of z naught, you can write z naught as well, comma phi double dash of z naught, and so on, are continuous. Because for calculating the value of phi dash of nth derivative of phi z naught value, you need to go for this. You need to have all these derivatives existing basically. For example, like functions like e power z, sin z, cos z, all these things. Okay. So this is just a result I am giving you. Why this result is coming, I'll tell you in the next class. But right now we want to solve few GATE questions before going for the advanced topics in calculus. So I just want you to take this result. Okay, so please do respect this result and agree this. I'll show you why this result is coming in tomorrow's class. Okay, because we need to deal few excess topics in order to get that. Tomorrow class timings, it's 7:45 to 9:45 and then 10:30 to 12:30. Okay, in the first lecture we'll finish complex calculus. I hope, yeah, generally we finish. And in the second lecture we'll start linear algebra. Okay, matrices, which is common for all branches of GATE. I mean, all branches of engineering like CSE, IIT, and ESE, mechanical, civil, and all these things. So you can attend the second lecture. I mean, all the students can attend the second lecture. Okay, because it's in syllabus to all of you, and we'll start linear algebra matrices. Okay, don't feel matrices is very easy, and don't skip the sessions. If you miss, I promise you, you'll feel later. Okay, so see here. So we'll solve some GATE questions now based on this. So see here, the value of the integral C e power 2z divided by z plus 1 whole power 4 dz, where C is the curve mod z is equal to 3, is k pi I. Means the value of this integral when evaluated this path mod z is equal to 3 is k pi I. The value of k is dash. So they have given this answer as k pi I. So they're asking you what's the value of k. Could you please try this? I'll give you some time. Please try this. Yeah, there is second lecture, but not of mathematics. We have thermodynamics session at 10 o'clock. No, it's not at 10:30, it's 10 o'clock. So please tell me what's the value of this k. See, this is of the form phi of z into this point. So you should see this function is not analytic at the point where this z plus 1 is equal to 0. Okay? If you look at the point where this z plus 1 is equal to 0, the value of z should be minus 1. So first of all, see whether z is equal to minus 1 is within this path or not. If this z is equal to minus 1 is not within this path, then within this given path at every point this function is analytic, and the answer is straight away 0 because we have seen the result. But if you see this z is equal to minus 1 is lying within this path. So let us try to solve this. Mod z is equal to 3. If you see what is mod z, root of x square plus y square. So mod z whole square is equal to 9. So this is representing a circle with center 0, 0 and radius 3 units. So if you draw this, you have some circle something like this. This is real part of z, and this is origin, and this is imaginary part of z. And if you see the radius of the circle is 3, so this is minus 3i and this is plus 3i. So now this function is not analytic at z is equal to minus 1 because denominator goes to 0. So if you see, if the radius is 3, this value is 3 comma 0, I mean this point, and this point is minus 3 comma 0, and z is equal to minus 1, will definitely lie within this point. Okay, so z is equal to minus 1 is the point which is lying inside this path C. So if you calculate this, now see here, the function is of the form phi of z into z minus z naught whole power n plus 1. So if you see, given I is equal to integral over c e power 2z divided by z plus 1 whole power 4 dz, and we have e power 2z by z plus 1 whole power 4 is not analytic because derivative doesn't exist at this point, is not analytic at z is equal to minus 1 because this denominator goes to 0. It's obvious. So if z is equal to minus 1, this function is not analytic at that particular point, z is equal to minus 1. So if you apply this Cauchy's integral formula, if you compare clearly, n value is 3 but not 4. Okay, because in this formula that I mentioned you, I put n plus 1 here. So now if you have 4 here, n value is 3 but not 4. Okay, so you should keep a note of this. So if you compare with Cauchy integral formula, okay, so see here, e power 2z is continuous and differentiable because it's just a infinitely extending positive power series of z. So e power 2z is continuous at all points within C. So this implies I is equal to, see, function is e power 2z and n value is 3. Could you all identify n is equal to 3 and phi of z is equal to e power 2z and z naught is equal to minus 1. Are you all able to identify these three values? N is equal to 3, z naught is equal to minus 1 and phi of z is equal to e power 2z. Did you all identify all these things? Can you all understand why these three values are in this way when you compare this integration with respect to Cauchy's Euler formula, Cauchy's integral formula? Yes. So if that's the case, we can write I is equal to 2 pi I into, see, if n value is 3, you should go for the third derivative of this e power 2z. Okay? If phi of z is equal to e power 2z, this implies phi dash of z is equal to 2 into e power 2z. Phi double dash of z is equal to 4 into e power 2z. And finally, phi third derivative of z, because you want this nth derivative of this phi and n value is 3, you want this third derivative of phi. This is 8 into e power 2z. So now you need to calculate this value at z naught is equal to minus 1. So 8 into e power minus 2, because z value is minus 1, z naught value is minus 1 divided by 3 factorial. So if you simplify the things, 2 pi, okay, let us write this pi I separately because it's given in the form k pi I. So you want the value of this k. So 2 8s are 16 divided by 3 factorial is 6 into e square into pi I. So the value of this k is 16 by 6 e square. So if you simplify the things, 8 and 3, so 8 by 3 e square. Let us calculate what's the value of this. 8 by 3 e square, and then you will be getting value of k. Third derivative is minus 8. How come minus 8? 8 into e power 2z. See, you need to put z is equal to minus 1 here, but not here. Okay, please don't overlook the things. Please pay enough attention. Okay, Nagsai. So 8 by 3 e square. Now tell me what's the value of this 8 by 3 e square. I hope you know how to use virtual calculator now by this moment. What's the value of 8 by 3 e square? I want all of you to respond. Taking so much time, let me do the things. Okay, so 8 by 3 e square value we need to calculate. So let us see. First of all, let us calculate 3 into e square value. Okay, 0.36. Let me check. 3 into e square. So basically e power 2 e power x. So if you see 3 into power of 2 will give you e power x value. I mean e square value into 3. Let me write this. Okay, e power 2 value is this into 3. This is 3 e square, and you have to have this term divided by 8. So 1 by x into 8 will give you 0.36089 as the answer. So if you see, the answer for this is 0.36. 0.36, which is equal to 8 by 3 e square. Okay. Yeah, I hope all of you have calculated correctly. Yes. Good. So we are going for the next question. See, in the beginning, it's really, not that easy for all of you to identify all these things and solve the questions. But if you go on practicing, like I have put enough number of questions here, we'll learn. So please try to solve this question. Manoj, what's the meaning of analytic? For example, if you take this is a complex plane, if this is a point z0, if I say this f of z is analytic at this point z0, then along with this point within some neighborhood, means at every point within this neighborhood, this function should have derivative existing. Okay, this is called, then we say this f of z is analytic at this point z0. For the function to be analytic, the derivative should exist at that point and also at every point within some neighborhood of z0. This is what I have discussed when dealing analyticity. You can go to lecture 3, Manoj, if you want, in complex calculus. So please try the answer for this and tell me what could be the answer for this. Because of some unavoidable circumstances, I couldn't take yesterday's lecture because I informed you that I'll be taking on Friday, but I couldn't actually. So we are continuing today. Okay. Okay, I'll help you for this question. You can see here. I is equal to integral over c sine pi z square plus cos pi z square divided by z minus 1 into z minus 2. Correct? So can we write this as sine pi z square plus cos pi z square divided by z minus 2 minus, of course we have dz here, sine pi z square plus cos pi z square divided by z minus 1 dz. So you can split this integration at this minus sign. So if you split this integration, integral over c sine pi z square plus cos pi z square divided by z minus 2 dz minus integral sin pi z square plus cos pi z square divided by z minus 1 dz. Okay. Now these are two integrals which are to be evaluated along this path, and C is a closed path. Mod z is equal to 3, and just now we have seen this mod z is equal to 3 is a circle with center at origin and radius as 3 units. Option A, Monica, 2 pi I. Let me check. No, 2 pi I is not the answer. Correct answer is 4 pi I. Don't worry, by seeing perform, I am performing some ticks here. From tomorrow you can also perform. Okay, after telling you something called quasi-SSC-JE theorem. Okay. See, this function doesn't get analytic when z is equal to 2, correct? So z naught is equal to 2 whole power 1 is there. So the value of n is 0. So please solve this now. I gave you a hint. You can split it into partial fractions. Whenever you have z minus 1 into z minus 2, I mean z minus a into z minus b, such kind of things. So please solve. Okay, how I evaluated partial fractions. I can deal with this. So see here. Okay, suppose if you have some function like ax square plus bx plus c divided by x minus, something like x minus a into x minus b. And let us suppose here you have some linear function for the time being, 3x plus 4, something like that. You can always write this as a by x minus a, some constant c1 plus c2 divided by x minus b. Now if you take LCMs and if you compare the numerators, you will get values of c1 and c2. Okay. So see here, b 4 pi I, yes, that's the correct answer. All of you, Libya, you are correct. Nagsa, you are also correct. So see here, this z minus 2 means z is equal to 2 is a point where this function doesn't have a finite derivative. So if you see, the power here is 1. So n value is 0. If you compare this with Cauchy's integral formula, the n value is 0 because n plus 1, and if you see n plus 1 value is 1 in both the cases, so n value is 0. So the value of this integration is, and sin pi z square plus cos pi z square is just some polynomial function, so that's always continuous anyhow. So sin pi z square plus cos pi z square. See, polynomial I am telling you when you expand the series. Okay, normally they are trigonometric functions, but when you expand the expansions of sin x and cos x, then they appear as polynomial functions which are continuous and differentiable at every point. So if you see, the value of this integration is 2 pi I into 0. 0 plus 1 is 1. So n is 0 and this is phi of z. So 0th derivative of any function is the function itself, correct? Because if you are not differentiating the function with respect to any variable, then the function remains as it is. So this value means sin pi z square plus cos pi z square at z is equal to 2, because at z is equal to z naught, phi of z naught, correct? Divided by n factorial. N is 0, we have 0 factorial, which is 1, of course. Plus for this function, again this 2 pi I is constant, so minus of, because of this minus sign, sin pi z square plus cos pi z square at z is equal to 1, because this function is not analytic at z is equal to 1, divided by again 0 factorial. So this is equal to 2 pi I into, when you put z is equal to 2, sin 4 pi 0, cos 4 pi 1, 1 divided by 0 factorial 1, minus, when you put z is equal to 1, sin z square value is 1, so pi into z square is pi, sin pi is 0, plus cos pi is minus 1, divided by 0 factorial is 1. So this is the answer, 2 pi I into 1 minus of minus 1, which is 4 pi I, which is an option B. See, zeroth derivative means the function itself, correct? So phi of z naught itself is the value of this numerator. And if you see, phi of z is of the form sin pi z square plus cos pi z square. So phi of z is this value. Clear to all of you why this is 4 pi I? From tomorrow, you will be able to solve this question in a much simpler way. You can directly come for this part. See, I will tell you one technique here itself. If some of you can understand, please try to understand. If you don't understand, no issues. In tomorrow's class, you will definitely understand. See, z minus 1 and z minus 2 terms are here, correct? And if you see, both powers are 1. Means basically, if you have some function of the form phi of z divided by z minus a into z minus b. Okay, if you have some integration in this format, look, the answer is 2 pi I into phi of a divided by a minus b plus phi of b divided by b minus a. This is the answer. 2 pi I into, how 0 factorial came? Because in this, when teaching you Cauchy's integral formula, I told you n factorial here, divided by n factorial. Okay, so that's why, since n is 0, this 0 factorial is coming here. So if this is the case, the answer is this, if C is closed path. Okay, so now for getting this, yes, correct, Monica. So if these are ones, means if you have this power 1 in both the terms, answer is this. If you want, you can check 2 pi I into phi of a. If you take 1 point as 2, phi of 2 divided by a minus b. And if you see, 2 minus 1 is 1, that's what you have, plus phi of b into b minus a. And b minus a is 1 minus 2, that's why this minus came here. This is the answer, straight away. Okay, so please try this question, all of you. The value of the integral of c 1 by z square plus 4 dz, where c is modulus of z minus I is equal to 2. Means basically that's also a cycle. Of course, I permit you to identify the center in positive sense. Means basically in anti-clockwise sense. Please try to solve this question. 1 by z square plus 4 can be resolved as z plus 2i into z minus 2i. Correct? So now we can apply partial fractions again. Please try to solve this. See, I am giving some time for all of you to try these questions. Okay. See, as soon as I read the question, if I start solving, it looks easier for you, but in exam, things doesn't, look that fine. You should develop your thinking ability with the concepts that okay, because in exam, I'm 100% sure that all the 65 questions doesn't come from our notes. Whoever the faculty that teaches, doesn't matter. Okay. All the 65 questions doesn't come from the same notes that is with you. Doesn't matter how many pages you have. Okay. Directly with the concepts, you need to think. If you think, then definitely you'll get the solutions for the questions in exam. No comments yet. Okay, I'll wait for you. Please respond meanwhile. Zero. Let me check. So all of you see here. What's the path given? C is mod z minus I is equal to 2. So if you write z as x plus iy is equal to 2, so this is mod of x plus I into y minus 1 is equal to 2. So if you see this, x square plus y minus 1 whole square is equal to 2 square, means this curve is representing a circle. Oh, answer is 0. Good, let me check. So x plus y minus 1 whole square, x square plus y minus 1 whole square is equal to 2 square. So which means if you see, the circle is having the center at 0 comma 1 somewhere here, 0 comma 1. Next, radius is 2. So which means if you see, the circle could look something like this, where this point is 0 comma 3 and this point is 0 comma minus 1. Okay, I hope 0 is the wrong answer. Let me check, of course, anyhow. So 0 comma 3 and this is 0 comma 1 and this is 0 comma minus 1, because radius is 2. So the distance between these 2 points and these 2, of course I'm not drawing to the scale here, but you can see this distance could be 2 and this distance could also be 2. These are the coordinates 0 comma 3 and this is 0 comma minus 1, correct? So let me write this. We identified what's the case. Now function is not analytic. Function is not analytic yet z square plus 4 is equal to 0, which means z is equal to plus or minus 2i. Correct? If you see 0 comma 2i means the point 0 comma 2 will lie within the circle, but 0 comma minus 2 will lie out of the circle. Correct? So there is no impact of this z is equal to minus 2i because that point is lying outside the path C. So we'll talk about the points only which are not analytic within the curve C. So if you split this into partial fractions, 1 by z square plus 4 is equal to 1 by z plus 2i into z minus 2i. So if you see the case, 1 by z minus 2i plus 1 by z plus 2i. Okay, let us replace with a minus sign because we need to cancel this z in the numerator. So z plus 2i minus this, so into 1 by 4i, because if you simplify this, you will be getting 4i excess in the numerator. So if you simplify this, you will be having 4i in the numerator. That 4i I am compensating by dividing here. Okay, then this expression is same as this. So integral over C 1 by z square plus 4 dz is equal to 1 by 4i, because this 1 by 4i is a constant, into integral over the path C 1 by z minus 2i minus 1 by z plus 2i. And if you see here, this 1 by z plus 2i divided by z minus 2i dz. Can we write this function like this? This z plus 2i into z minus 2i can be written as 1 by z plus 2i as numerator and 1 by z minus 2i as denominator, because this function 1 plus z by 2i is continuous and differentiable at every point within this circle, within this path, correct? Because within this path, if the function want to be not analytic, then you should have minus 2i within this path C. But if you see, if at any point within this path, this function is analytic, so no issues. Now this is having 0 plus 1 form. So the value of this is 1 by 4i into 2 pi I into, see, this is a, this is a point z is equal to 2i is a point where this function is not differentiable. So we need to calculate this value at z is equal to 2i. 1 by 4i divided by 0 factorial, which is 1. So if you see, 2 pi I by 4i into 1 by 4i. So if you see now, you can cancel the things. 2, this gets cancelled. So I gets cancelled. Pi by 8i could be the correct answer. You can write this as minus pi by 8 if you want, because one can be written as minus I square, so adjusting some minus and I, you can write minus pi by 8i. Did you all understand this z is equal to plus 2i is only the point within this path C where the function is not analytic. This z is equal to minus 2i is lying out of the circle. 1 divided by z minus 2i is in the numerator. No, see, because are these two terms got z naught value is 2i, because if you put z naught is equal to 2i, which is within this path, the function doesn't turn out to be analytic. We can take 0, that's why I didn't consider this particular part. See, for the point lying outside, we can straight away take the integral value to be 0. Okay. Oh, I think some things we messed up here. This 4i is coming excess. So I think there is some numerical calculation mistake that is involved here. Let us rewrite the things a bit. Okay, so see here. Yeah, I hope this some numerically constant mistake is there. So see here. This integral 1 by z square plus 4. Let us take this step straight away. 1 by 4i into integral over c 1 by z minus 2i dz minus integral over c 1 by z plus 2i dz. This is what we have, correct? Now this integration is equal to 0 because this function is not analytic when z value is minus 2i and minus 2i is out of this circle. So definitely this integral is 0 because within this closed path C at every point this function is differentiable, correct? Because this function is not differentiable only at the points when z is equal to minus 2i and z is equal to minus 2i is not within this path C. So definitely within the given path at all points this function is analytic, and since if this is cyclic integral and this function is analytic, definitely this value is 0. So we have 1 by 4i into this value. Now z minus 2i we have within the point, so z is equal to 2i is the point where this function is not differentiable, but of course this is having n value 0. So if you see that 1 is at 2 pi I into 1 is as it is here divided by 0 factorial. So the answer is 1. Yes, 1 divided by 1 factorial. So I gets cancelled, 2 this gets cancelled, so pi by 2i is the correct answer. Yeah, as we guessed, there is some numerical mistake in previous analysis, but pi by 2i is the correct answer. Okay. This integration we have split it into partial fractions, and this integral is 0. Anyhow, this minus 2i is lying out of the path C. We have considered one excess 4i here, so that's why mistake happened. Yeah, no I, correct. This I is already cancelled here. Correct. I also cancels. So pi by 2, 1.57 is the correct answer for this. Yeah, correct. I doesn't, sorry, because I have cancelled this i's on both sides. Yes, Livia, I is cancelled. I did. So we'll solve 2 more questions before ending up today's lecture. Then we'll go for tomorrow's lecture. And tomorrow's lecture could be probably the last class on calculus because we have 2 hours session that could be enough to complete this complex calculus. And at 10:30 session that begins at, the session that begins at 10:30, we'll start linear algebra. Okay. Don't feel matrices is very easy. We have good number of questions in GATE exam, which are not that easy. Okay. So please solve this question. Did you all understand this question? Please tell me if there is some difficulty to anyone in this question. Why I have equated the integral to 0? Did you all understand this? I want all of you to respond. See, nearly some 40 people are online. So please tell me, did you all understand why we are, solving this question in this method? Yes, I want all of you to respond. Not 2 or 3. What else other people are doing? I'm waiting for answer for this question. So please try to solve this, all of you. Mod z is equal to 1 is a circle with center at origin and radius as 1 unit. So this is mod z is equal to 1 with center at 0, 0. Of course, this is real part of z and this is imaginary part of z. So now I is equal to integral over c z cube minus 6 divided by 3z minus I. So if you see here dz, of course, if you take 3 common in the denominator, 1 by 3 into integral over c z cube minus 6 divided by z minus I by 3, because whatever the Cauchy's integral formula I gave you for the form z minus z naught. Okay, here definitely there should be z. So to get z, you need to take 3 out. Dz minus 18, come with me, let me check. So this function is not analytic at the point z is equal to I by 3, and you know, since this radius is 1, this point is 0, 1. So definitely the point 0, 1 by 3 will lie within the path. Correct? So if you see this 1 by 3 into, since we have only power 1 here, so n value is 0. So 2 pi I into z cube minus 6 at z is equal to I by 3 divided by 0 factorial, which is 1. So if you see 2 pi I divided by 3 into, if you put I by 3 here, I cube is minus I cube is minus I divided by 3 cube is 27 minus 6. So if you multiply the things, 2 pi I into minus I into minus I is minus I square, which is 1. So this is 2 pi divided by 81 minus 2 6 are 12, 12 into pi I, 12 pi I divided by 3. So this is 4 pi I. So this is equal to 2 pi by 81 minus 4 pi into I. This is what we got now. Now what they are asking, if this is of the form a plus ib, okay, then b by a. B value is minus 4 pi, a value is 2 pi by 81. So if you divide these two, b by a is equal to minus 4 pi divided by 2 pi into 181. So pi gets cancelled, 2 gets cancelled, minus 162 could be the answer. Okay, minus 162, correct. See, when there is some multiplication in terms of z, before z, please take that constant out, okay, because we have the Cauchy's integral formula only for the kind of function z minus z naught whole power n plus 1. Okay, so for applying this Cauchy's integral formula, you should have z minus z naught form here. So whatever the numerical constant that is in front of the z, please take that out as a constant. Okay, please solve this question, all of you. Semicircle contour. Contour is generally some curve that is present here. D of radius 2. Given this radius is 2, so if this is the center, this point is 2, 0, and it's given 2i and minus 2i, of course, as shown in the figure. The value of integral d 1 by s square minus 1 ds, where s is sigma plus j omega. Okay, this is area axis sigma and this is j omega axis. Means basically the imaginary part that we are plotting for this complex number s is equal to sigma plus I omega, or j omega is a into I. The value of a is, okay, I think time is short, so please let me solve. I have 2 more questions, so that's why. So if you see, this function is not analytic at point s square minus 1 is equal to 0. So f of z is equal to 1 by s square minus 1 is not analytic at z is equal to plus or minus 1. And if you see, z is equal to plus 1 is lying within this point. Of course, yes is equal to plus or minus 1, because the complex number is denoted in terms of s. So s is equal to 1, 0 is lying within the curve, but minus 1, 0 is not within the curve. So we'll consider only s is equal to 1 is the point within this path C where this function is not analytic. Okay, so therefore integral over d 1 by s square minus 1 ds can be written as integral over c 1 by, this can be written as s plus 1 into s minus 1, and s plus 1 can be written straight away here, divided by s minus 1 ds. And if you see this function 1 by s plus 1 is continuous and differentiable at every point within this path C. So the answer for this is 2 pi I into this function at s is equal to 1. The value of this function at x is equal to 1 is 1 by 2. By 0 factorial, of course. So if you see 2 gets cancelled, pi I is the answer. So if this is A, the value of A is pi. Okay, correct. Or else if you want, you can resolve into partial fractions, both are same. Then definitely this integral 1 by s plus 1 ds will go to 0. So I hope you all understand this. Or else if there is some difficulty, you can talk to me. Can we move ahead? Yeah, pi is the correct answer, Nagsai. That's what we have got here. So see, f of z is equal to c0 plus c1 into z power minus 1. Then integral over this curve mod z is equal to 1 plus f of z by z dz is dash. So let us see the solution for this. What is given f of z? F of z is equal to c0 plus c1 by z. This is what we have as f of z. Now the curve is mod z is equal to 1. Yes, Pavina, it's correct. Answer is pi for that last question. So 0, 0, real part of z, and this is imaginary part of z, and this is the curve. Mod z is equal to 1. So if this is mod z is equal to 1, then let us calculate the term 1 plus f of z by z. So integral mod z is equal to 1 and a closed curve, of course, 1 plus f of z, which is c0 plus c1 by z whole divided by z dz. This is equal to cyclic integral. Oh, for this answer is D null side, correct? Yeah, answer is D, I guess. So cyclic integral over C mod z is equal to 1 plus c0 by z plus c1 by z square dz. So this is equal to 2 pi I into, now if you see z is equal to 0 is the point where this integration doesn't exist. So z is equal to 0 is already the point within the curve. So if you apply this Cauchy's integral formula, 2 pi I into, this is here n value is 0, so which is 1 plus c0 by 0 factorial plus here z square is 2, so the differentiation of this constant with respect to z is 0. So this is what we have. So 2 pi into 1 plus c0 into I is the correct answer. So 2 pi I into 1 plus c0, option D. Okay, yeah, all of you are correct. Usha, Monica, Payne, and all of you. So did you all understand why this is 0? Because here n value is 1, and if you take phi of z as c1, then the first derivative of the c1 with respect to z will be 0. Because if you have n here, you should differentiate this numerator n times, correct? So since the differentiation of constant is 0, the numerator corresponding to the second integral is 0, and you have 2 pi into 1 plus c0. This is the last question for the day. This is the last question for the day. So please tell me the answer for this. Please take some time and tell me the answer for this. If we solve this question, we'll close this session today and we'll go for next class on tomorrow. Again, I'm repeating, tomorrow we have 2 sessions as tomorrow is Sunday, and first session is from 7:45 to 9:45 and second session is from 10:30 to 12:30, and we'll finish off the complex calculus in the first session, and in the second session we'll start linear algebra, okay, which is common for all the branches. So I recommend all of you to attend that. What's the answer? 0, correct? Because read the question. The values of the integral over this path C is this. This function is not differentiable at z is equal to 2. If z0 is equal to 2 is inside the contour A, you can evaluate the answer. Some value you will be getting for A1. Okay, A1 is some value, which I am not calculating right now, but you will get some value because z0 is 2. So if you apply Cauchy's integral formula, you will be getting some value. But when z0 is outside the contour, what is the value of A2? 0. Okay? Because if some point at which the function is not differentiable is lying within outside the curve, then what happens? The integration with respect to that path C is 0. So A2 value is 0, A1 into A2. Some value of A1 into 0 is 0. This is a previous gate question actually. Understood? So if you don't know, if z, when z0 is lying outside the contour, the integral value is 0. If you don't know this part, then you will spend your time in calculating a1. Okay. So did you all understand this question? Why the answer is 0? Because a2 value is 0. Did you all understand this? Why I am writing this as 0? I want all of you to respond fast because our time is short actually. So yes, did you all understand why this is 0? Because a2 value is straight away 0. Okay, good. Then all of you understood this. Pen, Gayatri, Deepak, Pavina, Usha, Pavan, Livia, Monica. Okay, so Kamaluddin. Okay, fine. So if you have any doubts, you can talk to me in the comment box. Comment box in the sense, not in the live chat, in the comment box of the video. Okay, so if everything is fine, then we'll end up this session because I have a next lecture at 10 o'clock, a thermodynamics class. So please, if you have any doubts, you can comment me, or else that's fine. Thank you all. Then we'll meet tomorrow at 7:45 AM sharp. And I'm again telling you, don't miss second session of tomorrow because we'll be starting new chapter, linear algebra there. Okay. Yes, Papayan, I am providing you the notes. You can join the Telegram channel of Engineers Hub. Okay. Okay then, fine.